right, so start with the first one here. So our general formula for a circle, if you remember, is x minus h squared plus y minus k squared is equal to r squared. Okay, so remember the numbers in the circle, you change the signs. So the center point, because it's positive 4, should be a negative 4. So negative minus negative 4 is going to be plus. Okay, and negative 7, we change the sign to make it positive 7. So change the signs to get the center, and then we take the square root, okay, of the number that's in r squared, which is 225. Yeah, it's written that well. All right, and so we're going to get an answer of 225. It's going to turn out to be 15. Okay, so the radius is 15, center is a point negative 4, 7. All right, number 2, we're taking a look. We're looking for the measure of angle AEB, which is right here. This angle is inside. So remember the rule, inside is average. We take the average for average of the arcs. So these two chords are forming the angle. So we're taking the arc across, okay, and the other vertical angle, and we're going to get those two arcs. So I do 35 plus 87, and then divide by 2. Now, AEB is technically this angle, okay? So I'm going to figure out this angle first, BED, and then just take it away from 180, okay? So when we do this, we're going to end up with 35 plus 87, that's 12, 11. So 122 divided by 2, which is 61. So this angle is 61, and then 180 minus 61 is 119. That's the measure of angle AEB, okay? And that's equal to 119. All right, number 3. So we have a ratio AC to BC. So remember, we're going to attach an x on to both of these. So 7x and 2x. Those represent the expressions for the two arcs. So if this is 7x and this is 2x, we're trying to find the measure of angle CPA. So remember, this is outside. And remember what we said, outside is different, so we subtract here, okay? So we're going to do, first thing we're going to do is figure out x and then get the arc measures. So 7x plus 2x is equal to 180, since AB here is a diameter. We have 9x is equal to 180, divide by 9, and we'll get x is equal to 20. So the measure of the two arcs, we plug in, 7 times 20, okay, is 140, and then 2 times 20 is 40. So we have 140 and 40, and we're doing outside is different. So angle P here, or CPA, is going to equal the difference of the two arcs, and then divided by 2. So 100 divided by 2, which is 50. And that's the measure of angle P. All right, number 3 is we got a machine consists of a circular wheel, inscribed triangular plate is shown. All right, in the diagram, we know that these two segments are equal. So this triangle, okay, SEA here, all right, is going to be an isosceles triangle, since these two sides are equal, okay? And we're trying to figure out the length of SA. We want to know what is this length down here. So we have to use the triangle to get it, okay? So since these two sides are equal, this is an isosceles triangle, and these two base angles are equal. Now I know this arc, SE, is 140, so this angle is inscribed. So this is 70, which makes this 70. So if I'm looking for SA, I'm really going to pay attention to the triangle now. So what I want to do is drop an altitude, okay, from E straight down. And what happens is this is going to create a perpendicular bisector. So I'm really looking at this triangle, okay. I know that SE is 10, which means EA is 10. So this hypotenuse is 10. We're looking for this length. This is the same thing, okay? So if we figure out this, then SA is going to be 2 times that, okay? And we know that this base angle here is 70 degrees. So we're going to bust out some Sohcahtoa, or Law of Sines. So Sohcahtoa. We're going to choose the ka part because we have adjacent and hypotenuse. So the cosine of my angle is equal to the adjacent over the hypotenuse. I cross multiply. Okay? And then remember SA is 2x, so we take 10 cosine 70 and we double it. Okay? So SA is equal to 10 times the cosine of 70, and then we're going to double this. Okay? So grab a calculator. 10 cosine 70 is 3.4202. We double it, and then we're going to round to the nearest tenth, and this should be 6.8 for that answer. Okay? Number 5, we have arc QT, which measures 140 degrees. Angle P is 40 degrees, and I want to know the measure of my arc RS. Now remember, this angle is outside. So remember we talked about it. Outside is different. So we're going to subtract. So we're going to do big arc minus small arc. Okay? All right? Divided by 2 is equal to the angle. So 140, take away. We'll just call this x for now. X over 2 is equal to my angle, which is 40. I'm going to cross multiply and get rid of the 2 first. So 140, so I'm going to have like a 1/2 x here, okay, is equal to 80. And then I want to switch the x and 80. I want to switch these 2 spots. So I'm going to add x to both sides, okay, and at the same time I'm going to take away 80 to make this go on the other side, all right? So I get 140 minus 80 is equal to x, and this is 60. And that is the measure of arc RS. All right. Okay, on to the next page. So looking at number 6. Okay, reading the question again, I can already see I have a ratio. So remember, this is x and 4x. And I know I'm looking for the measure of the angles. Remember, inside, right, average, central is the same. Inscribed, where it's on the circle, is half, and outside is going to be different, so subtract. So angle DBC is located on the circle, okay? So this angle is considered to be inscribed, okay? So it's half. So I need to figure out this arc, and then I take half, all right? So AC is x, this is 4x, that's my semicircle, so that equals 180. So 5x equals 180, divide by 5, and x is going to equal 3 for 15, 36. Okay, so this is 36, this is 4 times 36, which is 24, carry the 2, how about 144? All right, and then angle DBC is half of that, so that's 72. Okay, there we go. Number 7, okay, remember the hat rule. Sides of the hat are equal to each other, so these 2 are equal, okay, these 2 are equal, and then those 2 are equal, okay. So it says, get out of there, you. It says that AF is 6, so this is 6, so is the other side. CD is 5, so EC is 5, and BE is 4, so BF is 4. Perimeter, so we just add the sides, so 11, 10, and 9, so perimeter, 11 plus 10 plus 9, which is 30. All right? Number 8, we're talking about segment lengths. So remember, we have 3 scenarios. We have segments that intersect inside the circle, okay? This is going to be the part of the first times the part of the second equals part times part. We have segments that intersect outside the circle, forming a tangent and a secant. This is tangent squared equals the secant times the outside segment. And we have two secant lines, okay? And this is our secant times the outside for the first segment equals the secant times the outside for the second segment. So these are the three pictures we're essentially thinking of besides the hat rule. The hat rule is the two tangent lines, and these are just equal. So two tangent lines are just equal. So just remember that, okay? Those are the four setups. So look at the first one. It's this secant picture right here, okay? So we know AD is what we're looking for. We know that AB is 24. We know AE is 8. And AC is 42. So if it's secant, like this one is, it's the secant times the outside, the sec out, is equal to the secant of the second line times the outside piece. So the secant for the first line is 24. The outside piece here is x, and that's equal to the secant on this side, which is 42, times the outside segment here, which is 8. So we get 24x is equal to 16, how about 336? We're going to double check that because, we got a calculator. And we're going to divide out by 24 to get our answer. And this is going to equal 14. So now, does it ask you for x, or does it ask you for something else? We're looking for AD. AD was x, so this is indeed 14. Go back and double check. Make sure you're not looking for something weird. Like maybe they asked for DB, okay? Just go back and double check. Okay, this second one here, the second one, number 9, is this option, this tangent secant here, okay? So the tangent line is the measurable part from P to A. That's considered to be our tangent, okay? Remember, this is the entire secant, and this is the outside piece here, okay? So tangent squared is equal to the secant times the outside segment. I'm looking for AP, we'll call that x. The whole secant has a length of 12, and the outside piece is 4. So secant is x squared, tangent squared is equal to 12 times 4. So x squared is equal to 48. And then I'm going to take the square root of both sides. So x is equal to, and when we simplify 48, right, if you want to break down your tree here, is 6 and 8. So 3 and 2, 4 and 2, and then 2 and 2. So I got a 3 and 1, 2, 3, 4 2s. So 3, 2, 2, 2, and 2. So we're circling sets of numbers here, okay? Remember, two numbers to a set. So there's a set. This is 4, and this is 4. But when we take the square root, I take out 1. So remember, the twins broke out of jail, but only one survived, right? So I get 2 times 2 with a radical 3 left over, which is 4 square root of 3. Twins broke out, only one survived. All right. Number 10 on the next page. We're getting there, slowly but surely. So number 10, got a diagram below. I'm looking for segment lengths. So remember the rule, we're doing part times part for this one. So we take this chord, we cut it into these two parts. We're going to multiply those two together. We got this chord, we just cut into those two parts. We're going to multiply them together. So CE is 10. ED is 6. AE looks like 4. And AB, I don't know, look like, I got no idea, right? So, the first chord, CD is the first chord, okay? So this is going to break up into 10 times 6, part times part. The second chord is AB. That's going to break up to 4 times x. So 60 is equal to 4x. We divide by 4 and give me all your 15s, because that's my answer, okay? And that's the length of EB. All right, number 11, we want to show that this equation right here is a circle. So first thing I have to do is multiply out. So when I multiply, we do x times x, and x times negative 6. So this is x squared. minus 6x. The negative 2 gets distributed second. Minus 2x and plus 12. Okay? So this is going to turn into x squared minus 8x plus 12. Moving on to the y's, y'all. So y times y is y squared. We're going to do plus 11y minus 5y and minus 55. Okay? Combine like terms. So plus y squared plus 6y minus 55. So the first question, does the negative 12 and the 55 help us? And the answer is no. Okay? This is not, right here, does not complete a perfect square. So we're going to move the 12 to the other side. Likewise, we are going to move the 55 to the other side as well because that number does not help us. So I get left with this. X squared minus 8x plus y squared plus 6y is equal to, looks like 43. Now I'm going to complete the square. So remember, I'm taking b, so it's ax squared plus bx, right? We're going to do b over 2 squared. We're going to add that to both sides, okay? And it's going to factor into a plus, sorry, not a, ignore that for now. All right, so take a look at the first one. X squared minus 8x, that's the first grouping here. So we want to complete the square here. So we're going to do b, which is negative 8, over 2 squared, which is negative 4 squared, or 16. So I have to add 16 to turn this, okay, into a perfect square. And I add 16 to the other side. Likewise, for the y's, okay, 6 over 2 squared is 3 squared, which turns into 9. I have to add 9 to both sides. All right? And so this turns into x squared minus 16 minus 8x plus 16, and then y squared plus 6y plus 9 is equal to, and then this becomes 63 here. That's not right. How about 68? Just forgot the other side of the 3, right? All right. So this first part right here is going to factor into, there's my negative 4, so it's x minus 4 squared. This guy is going to be y. Remember, right before we square it, it's plus 3 squared, and this is equal to 68. So there's my equation of the circle. So the center, change the signs, is positive 4, right, and negative 3, and then the radius becomes the square root of 68. And there you go. Okay. Number 12, we want to graph a circle. So remember, we need the center and radius. So for this circle, the center is the point negative 4, 2, and my radius is 4. And for this circle, you can kind of think of this as x minus 0 squared, right, plus y minus 0 squared equals 9. So the center is the point 0, 0, and the radius is 3. Okay? So I'm going to go over 2, negative 4, 2, plot a point. I'm going to go up 4, right 4, down 4, left 4. I'm going to draw a curve in. Remember, when our curve to extend to 4, don't really go beyond it, don't go in front of it, okay? All right, there's my first circle, okay? Second circle, we'll do it in red here, is 0, 0, center, 3, 3, left, right, up and down. Draw my curve in, okay? All right? So, and then I'm going to, because there's two graphs, I have to have the equation on here. So x plus 4 squared plus y minus 2 squared equals 16. And here's x squared plus y squared equals 9. I got my axes labeled. We're good to go. So we want to determine the distance between the two centers. So if you think about it, right, I have to go from this circle down 2 and then right 4, okay, to make that right triangle. So if you want to use Pythagorean theorem, by the way, C and B are the same thing, so just do one of them, okay? If we use Pythagorean theorem, a squared plus b squared equals c squared, or our distance here. I'm going to do negative 2, or really just 2 squared, plus 4 squared. And then this is 4 plus 16, which is 20. Let's do simplest radical form because it says 2 right there. So, square root, remember 20, right, is 4 and 5, and then 2 and 2. So this becomes 2, 2, and 5, okay? And we're circling our set of 2's. Twins escaped, 1 survived, and we get 2 radical 5 for C, all right? If you were going to do the distance formula, it's the square root, so x2, so if you want to think of it like this is the point for negative 2, so negative 4 minus 0 squared plus 2 minus 0 squared, and this is going to turn into negative 4 squared plus 2 squared, and we're going to get the same thing here. 16 positive, remember that, square and negative, you get a positive. There's my radical 20, and then we'll simplify. On to the last one. Turn it on to page 4 here, people. Okay? So we're starting with number 13. When we get to it, when the board decides to turn the channel. All right? So center of circle O is 2, 3. The coordinates of the point P that are on circle P, all right, are 5, 7. So OP is a radius. What's the equation of the circle? So I have the center, so this is H and K. I don't have the radius. But if you think about it, okay, here's O, center, point P. That length is the radius. So I need the distance from O to P, okay? So 2 ways. One, we're bopping out the distance formula, right? x2 minus x1 squared plus y2 minus y1 squared, or I'm using the old leapfrog. So from 2, 3 to the point 5, 7, right, I have to go up 3 and then up 4. So this is my change in x, that's my change in y. That's A, that's B, let's go find C. So A squared plus B squared is equal to C squared, 3 squared, plus 4 squared, okay, right, 9 plus 16 is 25, and this is 5 when you take the square root. So that's the radius. If we plug in here, okay, x2, second point, x coordinate, 5 minus first point f coordinate, 2 squared, plus second point y coordinate minus the first, and we're going to get 3 squared plus 4 squared, that's 25, and the square root is 5. And that's my distance, all right? So that's technically the radius. So the center, right, equation, x minus h squared plus y minus k squared is equal to r squared, and then plug it in. So take the center point, okay? Remember to change the signs. So it's x minus 2, quantity squared, plus y minus 3, quantity squared, equals r squared. Remember, r is 5, so this is going to be 25. All right. 14, remember this is technically x minus 0 squared. So the center, change the signs, is 0, negative 3, and the radius is the square root of the number from the equation, so square root of 13. Okay. Equation of a circle, given the diameter, so 2 things we need. The center, remember, is the midpoint, and the radius is the distance, okay, from the midpoint to one of the points, okay? That's kind of the easiest way to think of it. Or it's half the distance of AB, so it's up to you. So midpoint, okay, is average. So I'm going to do negative 4 plus 4 over 2 for the x's. 2 plus negative 4 over 2. So we got 0 over 2, negative 2 over 2. So the center is the point 0, negative 1. There's my center, okay? Radius. I'm going to go from 0, negative 1 to, let's say, negative 4, 2, okay? So I'm doing distance. All right, x2, so we'll grab the point. We'll grab negative 4 minus, remember, we're going back to the center, so 0 squared plus 2, make sure it's from the same point, minus negative 1 squared. The distance is equal to, oh, I already see what it's going to be. So negative 4 squared plus the positive 3 squared, okay? So this is, once again, 25, and my distance is 5, and that's my radius, okay? So center, right? X minus h squared. Plug it in, change the sign. That's x minus 0 squared plus y minus k squared. So plus y plus 1 squared equals r squared, r is 5 squared, we're going to get 25. This is okay if we just want to put it as x squared plus y plus 1 squared equals 25. That's also okay. So either one of those is good. And the last but not least here, just double checking. Number 16. Okay, step 1, group the x's and y's. Get the number on the other side. So we're going to group this. Okay. Step 2, complete the square. So 4b over 2 squared is 2 squared, or 4. So add in 4 to both sides. So this is x squared plus 4x plus 4. Boom. Negative 8 over 2 squared is negative 4 squared, which is 16. So I'm going to add 16 to the y's and to both sides. So plus y squared minus 8y plus 16. We're adding 20 to 16, that's 36. Okay, and this first one is going to go into x, remember, plus 2, okay, squared, plus, remember the minus 4, y minus 4 squared equals 36. There's our circle, center, change the signs, negative 2, 4, radius, take the square root, and we get 6. All right, guys, that's it for the review sheet. Study up. See you for test tomorrow.